4 electric vehicles, 4 fires, and a whole lot of fire blankets. I spent another 2 weeks in the fire lab proving once again that watching things burn is technically research. Seriously, why didn't anybody talk about this type of work on career day? You found Stashed. I'm Pat, firefighter and automotive engineer researching EV batteries since 2018. This wasn't chaos. It was a carefully designed set of experiments to test how real-world suppression tactics hold up when electric vehicles go into thermal runaway. This will be my 5th video covering different aspects of a 3-year study on electric vehicle fires, and it's all conducted by the Fire Safety Research Institute, part of the UL Research Institute. Just as a reminder, I'm a technical panel member on this project, one of 17 different people providing outside expertise on the project, so let's get into the details. Before lighting something on fire, you have to figure out how to get that thing on fire. And for these experiments, the researchers want to make sure the batteries go into thermal runaway.
Yeah, so what you see next to me is our gas supply for the experiments. So we do use a propane burner. It's a turkey burner, actually, a pretty available off-the-shelf kind of turkey burner. And what we do is we send a pre-mix of propane and air, just ambient air, but at pressure, through these braided lines and out to the burner. And we do that so if you just put propane out of a propane burner, there's a premix at the very end. That can only draw in so much air, and so you get pretty tall flames. And so we premix a little bit of air in before that. That allows us to get much shorter flames, much more intense heat, without spreading the flames out to sort of the rocker panels and the other combustibles on the vehicle. And we can just focus the heat on trying to push that battery into thermal runaway.
So there's a real big advantage to that, so we don't get the rocker panels, because if we get a cabin fire, that's technically bad for the experiment, I would assume.
Yeah, absolutely. So the primary objective is to examine the situation of a car fire with the battery involved. So we really want to make sure we're pushing that battery into thermal runaway, not getting a cabin fire and being unsure of the state of the battery when we start suppression or when we start our firefighting activities. We want to make sure we have battery involvement.
Now, from what I've seen, you dial in that mixture, but then you have some type of remote control capability on the flame itself, the intensity of that heat.
Yeah, so the way we control the flow of air is just a needle valve right here on this tank. The way we control the flow of propane is through what's called a mass flow controller. And so that takes propane out of a pretty normal, this is just a giant version of a barbecue grill propane tank. And that controls the mass flow rate of that propane through the line and out to the burner. So if we want more heat, we can add more propane. If we want to premix a little more, a little bit less to change the size of the flames, we can do that with both propane and air as well. So we had an example today where the flames are getting a little too large, starting to light that rocker panel material on fire maybe. And so we can dial back the fuel in that mixture, and that gives us the adjustability on the fly.
Getting a high voltage battery for an electric vehicle to go into thermal runaway is surprisingly difficult, and they've figured it out through a lot of different trial and error. But now that we're towards the end of this 3-year study, they're doing a really good job. Once battery ignition is confirmed, and they do that through a number of different ways, but primarily there's thermocouples inside the battery case. They start a 6-minute timer, and that's meant to simulate a typical fire department response time, fairly average across the US. And just listen to the sounds of thermal runaway. The exact noises, they vary based on cell construction. But take a listen, let me know what you think. The video just does not do it justice. It's genuinely impressive to hear in person. Before the crews actually make entry to start suppressing this fire, let's talk about how FSRI measures what these firefighters are exposed to. It's really important in the real world to understand what that looks like. It all starts with turnout gear swatches.
We have a couple different sets of PPE swatches. So we have our 2 stationary stations. This distance is 15 feet off of the back of the vehicle. And it's just to gauge what kind of contaminants are able to be deposited on the gear itself. And then we also have some PPE swatches that are going to go on the firefighters. And those will be able to get us different data points on just what can be deposited on the gear itself, and then a more realistic gauge of contamination for firefighters who are walking and moving through the scene, moving in and out close to the fire, and see what kind of contamination levels.
And after you look at what the contamination is, are you actually washing the gear and trying to understand how you can get that contamination out as well? Is that part of the project?
Yeah, so cleaning is definitely a part of the project. So looking at what's getting deposited on the gear itself, and then looking at a couple different cleaning methodologies, whether that's going to be the traditional extractor that most firefighters already have equipped to their fire stations, and then seeing if there's more specialized laundering techniques that are required for more specific contaminants like heavy metals that are more relevant to the electric vehicles. Those cleaning methodologies like CO2.
Is there anything that you've initially seen with these samples?
Yeah, so I'm still going through the data, but the two types of contaminants that we're looking at are heavy metals and PAHs, or polycyclic aromatic hydrocarbons.
They're looking into more than just contamination in the turnout gear. So what are you working on here?
Right now, I am getting all the components together to put sampling pumps in a pack and attach it to Firefighter's SCBA. Basically getting all the tubing lengths cut, getting all the parts assembled, and then figuring out how long everything needs to be, and then zip tying it to the outside.
What are the pumps sampling for?
We're sampling for polyaromatic hydrocarbons, VOCs, metals, and hydrogen fluoride.
There are a number of blue pumps in a bag positioned behind the firefighters. Foil protects the hoses, and all of the samples are collected at shoulder level. Now that 6 minutes have passed, it's time for the crews to make entry. In the first two experiments, the vehicles were only covered with a fire blanket. In the second two experiments, crews also used a fire blanket, but then they flowed water underneath the vehicle using an undercar pancake nozzle. Each experiment involved two vehicles with different battery cell constructions, one using cylindrical cells, the other using pouch-style cells. I often get asked about the water contamination from these fires. A large pan is placed under the vehicle, and if you look, you'll see a pipe that carries the runoff a good distance away. Water samples are collected periodically through this experiment, and they're actually sent out for analysis. Remember, the researchers aren't just lighting a car on fire and watching it burn. It takes a coordinated effort by many hands to capture a ridiculous amount of data. Just like all the other experiments that I've covered in past videos, they're capturing temperature data, heat release data, environmental data, both outside the vehicle but also inside the vehicle.
So here we have a Fourier transform infrared spectrometer that we're sampling gas from the cabin of the car, passenger rear, and we're basically scanning across the whole half of the infrared spectrum and seeing what gases we can capture from inside the cabin.
Okay, and what kind of gases are you seeing?
Mostly we see carbon dioxide, carbon monoxide, water, which are standard combustion products. In addition, we can also see hydrocarbons that are part of the combustion reaction, both from the car's cabin as well as the battery pack. One thing that we're seeing in particular is when thermal runaway starts, we see some of the carbonate electrolytes from the battery in real time.
I assume that's like that big spike we see right there on the graph?
Correct. This is from start of the experiment to until now, and you can see different events that are represented here as they change the concentration of gases around the probe.
And one thing I noticed was like the CO, the CO2, the materials from the battery were significant, just really high in the parts per million.
Yeah. The order of magnitude, of course, the fuel is more when the battery gets involved, so the combustion products would be higher in quantity compared to, say, just the cabin. So that you see that clearly here in terms of orders of magnitude of gas.
When it comes time to remove the fire blanket, you have to do it with extreme caution. The blanket is trapping heat, flammable gases, a really rich mixture, and once it's pulled back, you could have a deflagration, but you also have the possibility of a sudden rush of oxygen that could cause those Class A materials, again like the seats, the plastics, the foams, the rubbers, they can reignite almost instantly. In each case, after the fire, the blankets were removed from the vehicles and laid out for examination. The researchers needed to document any damage, but they also needed to look for any contamination.
For this test, we deployed the fire blanket. And what we've done is we've took some wipe samples before it was deployed, pre-test. Now the blanket's been removed off the car. We flipped it so it's upside down, so the inside parts of the blanket are up. We took some surface wipe samples. We also took some sections, actual swatches out of the blanket. And now what we're preparing to do is basically a decon of the blanket. We've got some detergent, like a deck scrub brush. We're going to go through, clean the blanket as we would if at a fire department, and then we're going to do those again. We're going to take some wipe samples. We're looking for PAHs, the polycyclic aromatic hydrocarbons on the surface, and then also heavy metals. And then, like I said, we're going to take swatches out of it. We'll look at those swatches for the same things. We'll look at PAHs or heavy metals that are actually embedded into the material.
Now, where are the swatches actually going? Do they go to an external lab or internal?
Yeah, so internal to us, our postdoc, Chandler Prober, will take those, and then working with North Carolina State, he'll take those swatches down there and actually extract the contaminants from the swatches there.
Now, what's your opinion of the contamination that's currently on the blanket?
So it varies across the surface of the blanket. We're seeing some spots maybe that were hotter that appear to actually be a little bit cleaner. We're seeing some areas that have a tar almost like substance that's very sticky and very tacky. And then in some places we're seeing a very like slippery surface on top. Maybe where like an oily substance is mixed with water that was used in suppression. So we have a whole range of contaminants at this point, and it's too early to try to say what's in them. I think it'll be interesting to see what comes out of it. I'm interested to see how well we can clean it and what remains. I think the big question is, as a fire department, how do you handle this post-incident, right? So it's unlikely that immediately post-use, like we have here, we can lay it out and decon it on scene, right? This is probably something that's going to be packaged up, taken back to the station, cleaned on the apron or whatever there. And I think that handling piece of that post-exposure, post-use exposure to the firefighters will be an important piece for us to capture.
Yeah, and there's a lot of people that, well, number one, this blanket is technically a reusable blanket, but there's a lot of people that have questions about how reusable these blankets are, so it'll be good to get answers on that.
Yeah, that's what we hope to find out.
I want to share some of my observations and opinions from these experiments. To start off, the team puts in an extraordinary amount of effort. They spend 2 full weeks in this building, from sunrise to sunset. Many times they're doing back-to-back burns, and there's a ton of work required to reset each experiment. And that's just what I'm seeing when I'm here. That doesn't even include all the prep work being done beforehand to make sure everything runs smoothly once they arrive. Realize that most of these researchers are traveling to this location, just like I am. The first set of experiments only used a fire blanket. In a way, it didn't go quite as planned. One of the vehicle's batteries, it never went into thermal runaway. Check out these 2 videos and let me know in the comments, which vehicle do you think is actually in thermal runaway? It's pretty difficult to tell, believe it or not, and I'll give you the answer in a moment. Let me start out by saying that only firefighters in full protective equipment, including their self-contained breathing apparatus, SCBA, should be putting a blanket on a fire like this, a vehicle fire like this. I see some advertisements out there showing the average person without any protection putting on a fire blanket, but you don't want to get anywhere near that. I also see a lot of wild methods being taught for applying a fire blanket. Multiple hose streams, kind of treating it like a propane fire. Super long straps, pike poles. All these methods, they're designed to keep firefighters away from the heat. So I wanted to hear from the actual guys in these experiments putting the blanket on, since they were right up next to the vehicle. See how that heat was through their turnout gear.
With the heat off the car, through my gear, I really didn't feel anything. Just slightly warm, and that was after the 10 or 15 seconds.
I didn't think the heat was too bad. Just with keeping it lower, I think was the key to it. You have to kind of, once you got it over the top of the roof, just kind of immediately go to the floor with it to try to kind of snuff it out, try to push out the flame out the backside and not be in the path of it.
Okay, that blanket's about, 90 pounds, somewhere in there? It's a
About
pretty
that.
heavy blanket.
Yeah,
How
it's
did it
pretty-
go as far as weight goes? Did it feel real heavy?
It seemed like it was dragging on the car a little bit. Not horrible. I felt it grabbing on things, but it could have been from some of the tests, apparatus that we have out there. But I think overall it went over pretty smoothly.
So I noticed that I became stuck on the pan, and in order not to rip the tarp, or the blanket, excuse me, I lifted my arm a little more, and in typical fire fashion, it rose to the highest point and came out right at me. So when we are lifting this blanket and pulling this blanket, it's going to be a good idea to, as soon as you're able to slide, keep the blanket low and keep that heat away from you. It's going to come up and meet you where you're holding it.
Even after the fire blanket was deployed, you could still hear the batteries reacting. Cells were popping off underneath. It's a reminder that the fire blankets don't stop thermal runaway. They just contain what's already happening. If you've ever been in one of my classes, you know that I talk about the pros and cons of using a fire blanket. One of the biggest drawbacks is you're trapping a significant amount of flammable gas under that blanket. A lot of nasty gases. They stayed really low to the ground. It was actually pretty eerie. Earlier, I mentioned that one of these vehicles didn't go into thermal runaway, and while that was technically a failure for the experiment, it still provided valuable data, because now we have a direct side-by-side comparison of a vehicle fire with thermal runaway and without thermal runaway. Let's see who guessed correctly. Experiment T was the vehicle that did not go into thermal runaway. Experiment M, that's in thermal runaway, baby. Now, after the vehicles burned, the batteries were removed and disassembled to evaluate just how effective the suppression methods were. One frustrating thing I always have when reviewing incidents around the world: generic statements like, that battery did not go into thermal runaway. Often that claim is made just by looking at the outside of the vehicle. Look at this picture right here. Does this look like a battery pack that went into thermal runaway? I'll give you an answer in a moment, but the only way to truly know is to disassemble the box and look inside. That's not something I recommend at all for a fire department to do. You should not be opening up a battery box or trying to remove a battery. But in this case, yes, the battery did go into thermal runaway. And that was the case for all but one vehicle in this study.
So we've come to the end of these experiments. What's the next steps as far as getting the report ready? I assume it's going to be multiple reports.
Yeah, close to something like that. So I think we've hit FDIC with our preliminary findings. The report's going to be basically what was in those preliminary findings, initial guidance on basic suppression tactics. That'll all be in one report. I'd like us to include what we just learned about fire blankets. We'll have some supporting things that are in the pipe after that. So that first report, we're looking to get out by August. What we'll need to do is take that draft report, send it through you and the others on the technical panel for review. And then once we've had your comments back, we can do a final draft. We'll also be developing a training module for our Fire Safety Academy. And so basically all the findings that'll go in the report. I know firefighters love to read a big, thick technical report.
Right.
We'd like to turn basically our mobile presentation that we give of the findings into a self-paced learning module, just like you'll find for our residential playbook, search and rescue, all of our, other research. We like to make that, available and something that's a little bit more palatable to the fire service.
Yeah, so a lot of good stuff is going to come out of this set of experiments, the last 3 years of work. Any spin-off projects? Do you see any other additional EV burns in the future?
Yeah, I think so. So now we'll go back internally and debate what projects we do from 2026 forward. There's a lot of questions about how to mitigate stranded energy. There are continued questions about the creation of explosion hazards. And then I think what we're most likely to see is, since we have all this momentum built up, we need to continue to look at those specialized tools. I mean, I want to reiterate that we needed to take the biggest bite of the apple to say, what can you do with the basic tools every fire department has? Okay, what about the cheap ones, blankets and undercar nozzles? Now, if we're leaving something on the table and we want better control, is it worth the budget of fire departments to go after some of those even more expensive, even more specialized tools? Things that can puncture the car and get water right into the battery pack. I think
Sure.
there's data internationally out there, but we have North American vehicles. They're slightly different, and our approach will be somewhat different too. We take a little bit more fundamental scientific approach, and I'd like to investigate the electrical hazards myself.
Okay. Yeah, one thing I'd love to see is, I know this ceiling can come all the way down to about here, so set up like a parking garage scenario and see what that looks like. I think there could be a lot of parking garage studies done. Realistically, I think any vehicle fire in a parking garage is bad. probably electric vehicle would be a nice comparison.
Yeah, absolutely. And I mean, we've done a lot to look at the source fire, and I think we need to now start tying what we're learning into whatever environment that fire would be in, whether that's the side of the road, which is basically what we simulated now, or if we start looking at a residential garage, a commercial garage, partially enclosed garage versus a subterranean garage. All those things can affect whether the gas is dispersing off a car. And, you know, fire risk is one thing, but explosion risk is something that's not very well understood right now.
Right. And explosion risk just isn't something that we have with a standard vehicle today.
Yep.
There's been real progress in understanding how EV fires behave and how firefighters can respond more safely and effectively. But this is just one piece of the puzzle. As electric vehicles evolve, so will the risks and the tactics. I'll be right here, breaking it all down. Until then, stay aggressive, stay smart, and stay safe.